Welcome to the Athlete Climate Academy, where we talk with athletes, scientists, and communicators about the critical conversations that we need to have about the climate crisis. And today's topic is one I've been doing a little bit of research on lately, so I'm excited to chat with our guest. Dr. Guimond is an assistant scientist at Woods Hole Oceanographic Institution. Her research focuses on coastal groundwater dynamics and permafrost hydrology, combining fieldwork and numerical models to tackle climate change impacts on coastal ecosystems. So much we could talk about. Julia, welcome to the pod.
Thank you so much for having me. Excited to be here.
Yeah, I'm excited too, because I'm really excited to learn a little bit more about what you study. You're on the other side of the pond from me. So we're on the same ocean, just different sides of it. So can you start off by sharing a little bit about your background, what got you to where you are today, and how you got interested in climate science?
Sure. I think if you would ask my family, they would not be at all surprised. I was that person that was always outside as a kid. Rain, shine, snow, just always outside. And so I think it was a natural progression. At university, I did my undergrad at Brown University, and I studied geology and biology. And actually, my research started in paleoclimate, and so I was studying the ways we can use leaf wax isotopes to better understand past climates. And I think through that, I was always just wanting to study what was happening today. It was interesting, but just always had an interest on the ecosystems that I grew up playing in, the wetlands that were my playground. And so when I went to grad school, that's when I transitioned to studying groundwater, salt marshes, and these ecosystems that I really cared about and wanted to, help protect with climate change. So
it's funny, I studied geology and astronomy. One of my favorite modules was looking at paleoclimate through studying pollen and how you can track the climate and track different types of plants across the world, looking at the pollen that they leave behind. And as the summer here in the UK at the moment, I know that everyone really hates pollen when it goes up your nose and causes you to sneeze. But it's really handy when you're trying to find out which plants are at which point in the development and in which places across the world. So now you're on coastal groundwater hydrology and how that's changing with the climate and things. Can you explain a little bit about what that involves and why you think this is so important?
Sure, yeah. So about 40% of the global population lives in coastal zones. Coastlines are, these pivotal points of trade and infrastructure, and not everybody knows that some of the ecosystems in the coastal zone hold more carbon per hectare than a tropical rainforest. So from so many different areas, coastlines, impact global populations. But as you can imagine, we say we're biased, but they're the most vulnerable to climate change. Sort of at this land-sea intersect, they have all the pressures from humans and climate change happening on land. They also have all this pressure from the ocean, like storms and sea level rise, and the atmosphere. And so they're really vulnerable to changes. And if you think about Arctic coastlines that are warming sometimes up to 4 times faster than the global average, that these are really systems that are transitioning really quickly. And so I think a lot about how climate change is impacting coastal ecosystems, coastal groundwater. I've been focusing a lot on the movement of saltwater into freshwater environments as you have sea levels rising, as you have more storm events, and what this means for the vegetation distributions, what this means for permafrost, and also the water that we drink. And so one of the projects I'm starting in a few months is a project actually thinking about when you get saltwater into coastal Arctic tundra, what does that mean for the greenhouse gas fluxes to the atmosphere? So those are things I think about every day.
Well, so, there's we lump in coastal ecosystems together, but obviously, depending on where you're on the planet, there are like so many different types of coastal ecosystems. You've got ones that are in the Arctic that are mostly frozen, where there's permafrost there, or just regular ice. Antarctica is another one where there's largely just ice around the entire continent. You've got desert ones, you've got forest ones, you've got ones with mangroves, you've got ones with, like, there's so many different types. What have most of your studies been on so far, and is it just now moving into Arctic?
Yeah, so a lot of my PhD work was focused on salt marshes, and I still work in salt marshes. So these are coastal wetland environments that are primarily grasses that can tolerate salt. And so these are in these temperate zones. And then starting after I graduated in my postdoc, I asked really similar questions, but in these high latitude coastal systems and these coastal Arctic systems. I now do about 50-50. I have sort of a nice balance, and I've created a way to do field work year round. So I go to the Arctic in the summer when there's groundwater, when I can, and then I do a lot of my salt marsh work in the winter, because it happens to be a time we don't have a lot of data, because not a lot of people like to go out in the winter. So it's a nice balance. Trying to
One of the saltwater marshes we have here in Wales is quite famous for having a farm on it that's rears sheep there. So they rear sheep on the saltwater marshes, and the sheep eat the brackish water, or the grasses come from the brackish water that's like this mix of salt and fresh from the river, and it gives it a special kind of taste, apparently. So there's all these different people relying on the coastal environment for different things. And if there's one thing I've noticed about climate change, isn't that, there's going to be winners and losers. There's stuff that's changing all the time, whether that's good or bad. One thing that we can definitely say is that there's instability coming, that there's changing. Like, humans rely really a lot on stability. So let's take the saltwater marshes and like that kind of environment to begin with. What are the big changes that we're starting to see in places like saltwater marshes?
Yeah, so I think probably one of the most visible changes is what we call ghost forests. So there's been a lot of attention on this recently, simply because it's so visibly striking. Marshes, as they respond to sea level rise and as saltwater migrates landward, we're seeing salt marshes transition upland. So they're moving into areas that were formerly these forest environments. The saltwater comes in and kills those trees that need fresh water, allowing these plants that rely on salt water to sort of move into that space. And so you can see these huge areas, particularly in the mid-Atlantic, that is salt marsh with dead trees everywhere. And I think that's really striking and a powerful image, and it's happening really quickly. You see it, marshes moving meters per year, which, takes your breath away. When you go year after year and you can see the change, I think it's pretty powerful.
Well, I think that there's and if you don't think about it for any length of time, it's true in a lot of science that, like, we only think about what we see. I'm definitely like that. Like, I don't eat things in my fridge if I can't see it. So I like to be able to see things, to like understand them. But the thing with saltwater intrusion and like the saltwater starting to impose in landward is that you just can't see it. So we think that like the line of the saltwater ends at the harbor or ends at where you can see it lapping up on the beach. But of course it can go much further in than that, right?
Yeah. And that's a huge struggle I have conveying my science, right? And doing my science. You can't see groundwater. It's not something that you can, just walk out into the tundra and measure with your hands. It's all in the subsurface. A lot of times we use vegetation because you can see it, sort of as tracking some of these changes. But otherwise, we use wells and use data to show it, which is not, not as compelling, and it's not as easy of a story to tell. I will say, in the Arctic, our groundwater is much shallower, right? So I work in areas where we have continuous permafrost. The depth of the permafrost is a maximum of about 1 meter, and so you similarly see vegetation changes, but everything is so much shallower, much more obvious.
So, vegetation is one way of seeing that, and obviously there's a whole ecosystem that relies on the vegetation in those areas, but also humans rely on that water that's under the ground. There's so much of the human population that relies on groundwater for its fresh water sources. And even if they don't rely on it for freshwater sources, they rely on it for agriculture, they rely on it for all these other things. I was recently in the Mediterranean, in the Camargue Delta, where the Rhone River runs from the Swiss Alps all the way through France, through some really nice wine country. I got to stay in a few vineyards. That was some of my best work. And then out into this delta where, the salt water is encroaching. And some studies done in the early 2000s were looking at what can we do to slowly suppress the intrusion of salt water. And one of the ways they found was to put in rice fields. So historically, they used to be vineyards down in that part of the world as well, but they found that flooding the fields with salt water and planting rice for maybe 2 years at a time, and then in the third year they can plant wheat there. It's just another way of slowly, literally holding back the tide. It's not going to last forever, but with the Rhone coming down as it does and them doing that, it means that they can continue to grow crops there as if it's a freshwater ecosystem. So what are the ways that we can continue to, I don't like using war type words to talk about this, to battle the incoming onslaught of saltwater and things, but what are the ways that we can kind of stem the flow of this thing that we'll see continue to intrude into our groundwater?
Yeah, it's funny that you talk about agriculture. I was just actually got back yesterday from a conference in Maryland on salt-affected lands in transition. And a lot of what we were talking about is coastal agriculture, where in the mid-Atlantic, you see some of the highest rates of relative sea level rise, and a lot of farmers are experiencing crop die-off because saltwater is coming in, or they're irrigating with saltwater because saltwater in the subsurface is coming in. And some of the ways we're thinking about is, allowing marshes to migrate into these systems. So essentially, just adapting. I think everybody has a different definition of what coastal adaptation is, what coastal resilience is. But one method is, allowing these coastal wetlands to migrate into fields that are no longer productive, but putting policies in place that incentivize and actually allow farmers to do that financially. But then there's also, policy is a huge way we think about coastal development and how we rebuild after storms. And it's really difficult conversations because it involves people's livelihoods, it involves people's homes and communities. But I don't think there's one right answer or one wrong answer. And it depends on the coastline and the stress that they're experiencing.
Well, and to go back to my wartime metaphors that I don't like to use, the people at the front line of this kind of stuff are the people on the coasts, and whether it's through events like storm surges or whether it's through the natural kind of rising of sea level, or the rising of sea levels caused by climate change, but through a natural process. The difficulty becomes, how do we naturally allow that to happen, and try and stay ahead of the curve a little bit, or do we try and fight back and do what people like in the Netherlands have done, people in Florida continue to do, where they literally pump that water back into the sea when it tries to intrude into where they live. You can't always do that with ground aquifers and that kind of stuff, because when the salt water's in. But is there anything that we're trying to do to literally, just try and get the water back out?
Yeah, that's a good question. That's definitely I'm not an engineer. I joke that I document climate change. Solutions are really hard. There's,
Yeah.
I think I focus a lot on protecting these ecosystems that we have now. Salt marshes are natural storm surge protectors. So we want them to survive with sea level rise because, they're worth a lot more than you would think just by looking at them. And so it's really expensive to get saltwater out once it's there. But I would argue it's potentially less expensive to protect what's already there, or at least allow it to migrate into areas that are no longer viable.
Yeah, we find that a lot with our changing climate, that, we're trying to do things sometimes that it might be more beneficial just to let happen. And to, like you say, to protect, I come across this with planting trees all the time, that people putting money into planting trees, but there's plenty of projects set up to just protect trees. Like, it's much more beneficial in terms of money, but in terms of carbon capture, just to protect what we already have. So, to protect these environments that you work on is key, I bet. So the difference then between, is it the same problems that we're facing in saltwater marshes and those kind of environments that are subarctic compared to the Arctic ones? Because you've got permafrost and just the cold temperatures that are different. What are the similarities and what are the different problems that you find working on those two different habitats?
Love that question. There are a number of similarities, right? So you have similar ocean pressures, right? You have tides in the Arctic, although they're much smaller in the areas that I study. With sea level, you have sea level rise in the Arctic, you have storms, and so they're experiencing different pressures. But permafrost does complicate things, and we have so much less data there, right? So what we know is based on much fewer data points than what we know about subarctic systems. The Arctic is experiencing some of the highest erosion rates in the world. Some areas are losing tens of meters a year of coastline, which is pretty staggering. I think one of my favorite visuals of thinking about saltwater intrusion and climate change in the Arctic is, I mentioned the aquifers are really shallow, right? So, and we don't necessarily do a lot of groundwater pumping in the Arctic. But one way we're seeing sort of saltwater intrusion expressed on the surface is tundra degradation. So the first time I went to the Arctic, which it was a number of years ago now, I was walking along the tundra just to see where I wanted to work. And you're walking along this green, lush tundra, right? You have green tundra grass that's about less than 30 centimeters tall. And it seems healthy. And you keep walking, and all of a sudden you're in this area that is completely degraded. So if there's vegetation, it's orange. The tundra's cracked and black and crispy in areas. And so I have to admit, I've never seen Lord of the Rings, but now when we go to these field sites, we refer to the degraded site as Mordor. And if you're working in the healthy site, it's the Shire. Or if you're talking to an elementary school, it's the Elephant Graveyard in the Pridelands. But that just is it's a pretty accurate visual of what saltwater intrusion is doing in these systems. Unfortunately, we don't have a lot of data on what that means for carbon, and that's what I'm sort of diving into for hopefully a long time, but definitely in the next 3 years.
Do you think we're seeing more kind of push to get data in those kind of locations now? Is the money being funneled into it, or is it still a spot where we just are going to need more and more and more money pushed into it for more scientists to do that research?
There's funding, funding's super competitive, but there is a huge effort to get more data. I think recently it's all these studies that have come out showing how rapidly the Arctic's changing, right? Under what we call Arctic amplification. So experiencing even faster than we feel like we're experiencing weather changes here. And so there's a big push to get some data. There's also pushes for other reasons, right? There's important infrastructure on the coastlines in the Arctic. And so I think there's a lot of attention that's warranted in studying these environments, but it can be really difficult, right? It's difficult on the personnel. It's difficult on the sensors. So collecting a long time series of data, which is really what we need, and collecting a lot of data requires a lot of effort.
And that's just to collect the data. And, there's always pushes from different funding bodies to study different things. Everyone has their own thing that they want to study. But that's also true for things like public policy. Like, it's obviously if somewhere in Boston or in Florida or somewhere coastal is experiencing saltwater intrusion or some kind of degradation or erosion of the coastline, then there's a big push to do something with it with public policy. I imagine that in places where there aren't a lot of eyeballs or a lot of people that are being moved on or being impacted by it, public policy isn't really going to be implemented in that area. And it might be that, in these remote locations that you get this, maybe it's Greenland, maybe it's the Arctic, you're not sure who owns that bit of land, or maybe that bit of land is owned by Russia, and like, how do you work with that particular government then to implement a public policy in that area? I imagine, like, how do you think about public policy, or how important is it in addressing in the Arctic areas things that happen there? Is there a lot of public policy going into it or no?
That's a good question. And that's definitely an area I don't have a lot of experience in. I work in areas that I work on the oil fields. So the areas that I'm doing research in are right adjacent to oil field infrastructure. I have not had a lot of opportunities to interface in areas, where coastal communities are experiencing these changes and trying to interface more with policy. And so I hope to more in the coming years, and can probably better answer that question after I've had some more experience in that area.
Well, it's just something that, that I often used to say, like, as a scientist, I do my science and that's it, kind of thing. And I think largely science is like, we've got something to concentrate on, we get the data, and then we translate it. Like, as a science communicator myself, I always think that the science isn't finished until it's communicated well. But then there is a little bit of me that's like, well, also that science should influence some kind of policy. And in places where the people have less influence, the people are more remote, they're just going to have less ability to influence the policy for that area. So I always love to see when science helps influence policy as well. And for climate change, it's going to be, we just have to do more of it. So in the coming years then, you say you want to be doing more of that. What are your future goals for, like, both your research and broader efforts in looking at coastal erosion, but also in the greater scheme of adding to the knowledge that we have of the climate changing?
Yeah. I'll lead off with more like the personal, potentially more policy and communication journals. Like you said, I hope in the coming years, sort of as I progress as a scientist, I'll sort of see more of a direct impact of my research on policies. I think, that's one of the reasons we do what we really want to do. I also would like to do a lot more science communication. So, a lot of what I communicate with my science is to other scientists at this point, unfortunately. But that's changing. I think in one of the earlier podcasts you mentioned sort of the importance of talking with your community. And I'll say a lot of my interactions these days are when I'm working at the coffee shop around the corner and somebody sees my screen that has like a presentation with word permafrost on it. And they're like, oh, what's that? Or they see me running models and ask a question. And those are some of my favorite interactions. I'm starting what I'm calling a SEEK program, which is Sea Education and Exploration from a Kayak. And so just got funding really recently on to develop a program for middle school girls to teach them how to sea kayak while also getting them in the field and doing field science. So that I'm really looking forward to developing that. And also just being more vocal about what the life of a scientist is like. I think, you said in the beginning of the podcast when you were chatting about, not really, putting a face to a scientist. And so one of the things that I think a lot about is collecting data and how we collect data and, what it takes to get this data that goes into the climate models and that goes into these policies that we're seeing. And I don't think everybody realizes, how much effort it takes, right? We're not only scientists, we're truck drivers in the tundra, we're, boat drivers. It can be pretty rigorous and difficult, and we do it in gear that's a conglomerate of gear from all kinds of different sports. I joke I have, a dry suit for kayaking and boots for fly fishing and mountaineering gear on top. And so doing a better job of communicating those aspects of science, not just the science that I study, to the world is something I'm looking forward to doing as I progress through the scientific career.
Absolutely. And I said it before and I'll say it again, scientists are the last true explorers, like doing a little bit of everything. And if it's one thing I think that our athletes can take away from listening to podcasts like this is that like those conversations do make a difference. Like the conversations we have with people about what's happening in our environment from people who've seen it before, and like mountain athletes, trail runners, sea kayakers, like you name the sport, if it's in the outdoors, they've seen something change over the last couple of decades. And it is terrifying, but we're aware of it. And with scientists like you, we're doing more and more to monitor that and make sure we know in which direction we're going, which is amazing. Dr. Julia Guimond is an assistant scientist at Woods Hole Oceanographic Institution. Julia, thank you so much for coming on the podcast. I really appreciate it.
Thanks for having me.